Hello everybody. Today our lesson is on some application problems. In the first one we're going to look at finding um, finding different designs for a box that we're cutting out of a piece of plywood. And so we have a piece of plywood that measures 4 by 8, and we want to talk about what are some different designs we could use and calculate the volume of these different designs and see if we can figure out what is the best possible design, maybe one that doesn't waste very much plywood and one that has a fairly large volume. So in the first step, if we think about the top, bottom, left, right, front, and back of a box, which dimensions must these rectangular pieces have in common? And so imagine we have some box. And so every box has 6 faces to it. It's a rectangular prism. And so what do the sides have in common? In other words, we could call this side the front side, the back side, the right side, and the left side. And then, of course, we have the top and the bottom. And so what dimensions do those sides all have in common? So we see that the left side and the front side and the right side both have to have the same dimension here, so that height needs to be the same for both of them. And then so if we called this length, width, and height, the left side, or the front side here, has to have the same length as the top of the box. The top of the box has dimensions length times width, and so they share that length in common. The top and the right side have the width in common. They both join together at that edge, and so they would both have to have the same width measurement. Now in step B, we're going to look at a couple different designs for splitting up this piece of plywood. So we have a flat piece of plywood 4 feet by 8 feet, and so we want to be able to cut all 6 pieces of the box. Remember, we have the top, the bottom, the left, the right, the front, and the back. So all 6 pieces need to be cut out of this piece of plywood. Okay, so just to give you an example, one possible way to cut these up would be, let's see, if I made 2 pieces that were 1 by 4, and then the next 2 pieces, if I made them 2 by 4, then remember what we said, they have to have the same, the other 2 sides have to have the same dimensions in common. So for the other 2 sides that I haven't marked off yet, they need to have a dimension of 2 and a dimension of 1 in order for this box to go together correctly. And so I need 2 pieces that measure 2 by 1, and so that would be like that. There's a 2 by 1 and another 2 by 1, and so that means this piece of the plywood would go to waste, because now we see that I have a box. If I use those 6 pieces that we cut out of the plywood, I would have a box that measures 4 this way, 2 this way, and 1 this way. So for example, the top and the bottom would measure 4 by 2, and so that is these 2 pieces. So this would be, for example, the top, this would be the bottom, and then the left and the right measure 2 by 1, and so that would be these pieces. So this would be, for example, the left side and the right side. And then the top and the bottom, or sorry, the front and the back measure 4 by 1, and so this might be the front and this might be the back. Okay, and so if we used that arrangement, we could certainly build this box. And then I'm going to calculate the volume just for this one. And so the volume, we know the volume of a rectangular prism is the area of the base times the height. And so the area of the base, that's the floor, would be 2 by 4. And then the height is 1. So the volume of this box is 8. And that would be 8 cubic feet. Okay, so what I'd like you to do now is in the other blank piece of plywood here, see if you can come up with another design, cutting the pieces with different dimensions, but remember you can't change the shape of the piece of plywood, and you have to have all 6 sides of the box by the time you get done. So there are literally infinitely many different ways that you can cut up this piece of plywood to form a box. So go ahead and see if you can try a different arrangement and see if you can improve on the volume. In our first example, we got a volume of 8. Maybe there's an arrangement that would come up with a better volume. Why don't you go ahead and try that? So press pause on the video player, and then after everyone's had maybe 4 minutes, 5 minutes to come up with a design, then go ahead and press play, and we'll see what people came up with. So another possible arrangement is I came up with one that doesn't waste any plywood at all, and that is if you cut this up in 3-foot pieces. So 3, 3, and 2, and then this would be 2 and 2, and so we can get all 6 pieces cut out of one piece of plywood without any wasted space. And so that particular arrangement would look like this. So the ends are going to be squares, 2 by 2, and then this is going to be 3. And so for this arrangement, we get a volume of, let's see, the area of the base times the height. So the area of the base is 6. The height is 2, and so now we get 12 cubic feet of volume. And so that is certainly an improvement over the 8 that we came out with in the first example. So let's see if there's anybody. Go ahead and raise your hand if you got a volume for your design. If you got a volume higher than 12, we'll see if there's a design. So if there's anyone in the class right now that got a volume greater than 12, if you could come up to the whiteboard and draw your pattern and show us how you got a volume higher than 12. Okay, now for the next problem, we're going to go to page 1058 and look at example 1. So in this example, we have some wax. We have 150 cubic centimeters of wax, and we're going to use it to make a candle. And we want it to be in the shape of a cylinder. And so we want to know what dimensions will use up all 150 cubic centimeters of wax. And we do have a constraint. We want the candle's height and diameter to be equal. Okay, so that means twice the radius is going to equal the height, because we're saying that the diameter is the same as the height. Okay, and so they went through and worked out this example for you. I'll talk through the different parts. The diameter of the candle is 2r, and so the height is also 2r, so we can say h equals 2r. And so now we know that the volume of a cylinder is the area of the base, which is a circle, so that would be pi r squared, times the height. And our height is 2r. And so here's the volume of any cylinder. If we replace the h with 2r, then we get pi times r squared times 2r. And simplifying that expression, we get the volume of this cylindrical candle would be 2 pi r cubed. And we also know that we want the volume to be 150 because that's how much wax we have. And so now we just need to solve for r. So if you divide both sides by 2 pi, the 2 pi's cancel and we get r cubed equals 150 over 2 pi, or about 23.9. And then there are a couple of different ways you could solve this equation. The author here showed that you can graph both of these. They said graph y equals r cubed. What we really want to graph on your TI-84, go to the y equals menu and graph y equals x cubed, not r cubed. And then for y2, graph 23.9, which is just the horizontal line. If you graphed both of those, this is the graph that you would get, and we want to find that intersection. And so just in case you forgot how to find an intersection, I'm going to go ahead and show you how you would do that. So you would type in, go to y equals. You can do this along with me if you'd like. So y1, we're going to put in x cubed, so x raised to the third power. And then for y2, 23.9. And then if we go to zoom 6, that's zoom standard. That'll set our viewing window to the normal viewing window, and we'll see if we can see the intersection. Of course, we don't see an intersection because look at our second line. Our line is all the way up at 23.9, and so we need to change our window. And negative values don't really make sense for this problem either, so let's set our x values to go from 0 to 10, and we'll adjust that if we need to. And then the y values need to go at least to 23.9, so I'm going to go 0 to 25 and graph that. And now hopefully we'll see an intersection. There's the cubic function, and there's the horizontal line. And so now we're looking for the intersection. So the steps for finding the intersection on your calculator is to go to second calc. So that's second, and press the trace button. That's calc. And then we're going down to intersection, which is option 5. And it's asking which one is the first curve, and it's showing us y1 up at the top, so press enter to accept that. Then second curve, it's showing us y2 at the top, press enter to accept that. And now it's asking us for a guess, so I'm going to move the cursor until it's fairly close to that intersection. Okay, it doesn't have to be perfect, just somewhere close, and then press enter. And it tells us the intersection is at about 2.88, or if we're rounding to the 10th place, 2.9. Notice also that the y value is 23.9. That's giving us that's the x value cubed, so that would be the radius cubed. Okay, so our radius is going to need to be 2.9. So the radius of the candle should be 2.9. Okay, now you don't have to use a graph to solve an equation like that. If we have, I'll show you another method. if we just have r cubed equals 23.9, one way you can solve that more quickly than using a graph is to raise both sides to the 1/3 power, because 3 times 1/3 gives us r to the first power. And so then if I raise 23.9 to the 1/3 power, that's a much faster calculation on the calculator. If I go back to my home screen by going second quit, I can just type in 23.9 raised to the 1/3 power, press enter, and I get the same answer, 2.88, and then we round that to 2.9. Okay, so that finishes that example. Now I'd like you to go ahead and try example B, see if you can fill in the blanks, and then use any method to solve. You can solve by graphing, or you can solve by using the exponent that I showed you in the previous example. So please press pause on the video player, and after about 3 minutes, then press play, and we'll see if everybody filled in these blanks right. Okay, so this time we have 300 cubic centimeters of wax, and we want our candle to be a square prism. So remember, that means there's going to be a square base, and so we can call that let's say they said let the length of the base be b, so that's going to be b times b, and then we have the height, and we want the candle to be twice as tall as it is wide, so the height's going to be 2b. Okay, let the length of the base be b, the height be h. The height h is twice the base, or 2b. The candle's volume, that would be the area of the base times the height, so that's going to be b squared times h, which in this case would be b squared times 2b, or 2b cubed. Substitutes, so they actually only wanted this, and then substitute 2b for h, so that's what I got here, so that would be b squared times 2b, and then simplifying gives me 2b cubed. So I just did it all together in one step right there to fill in those two blanks. And then substitute the given volume of wax. So we know we want 2b cubed to equal 300. And then we want to solve for b cubed. So as I said, there's different ways to solve that. You could graph the left side and the right side. You could divide by 2 if you want, and get b cubed equals 150. And so one way to do that is to graph on your calculator y1 equals x cubed and y2 equals 150 to see where they intersect. Or you can do what I showed you a little bit earlier, and that is if you have b cubed equals 150, you could raise both sides to the 1/3 power and get b equals, that's the cube root of 150, or 150 raised to the 1/3 power. 150 raised to the 1/3 is 5.313. And so filling in the blanks, if we were doing it graphically, we would graph y equals x cubed, y1 equals x cubed, and y2 equals 150. The coordinates of the intersection are, I didn't do the graph, I did it the other method, but we got 5.313, and we don't really need the y coordinate. If you did it graphically, you can go ahead and fill in whatever that number should be. The side lengths of the square base of the candle should be about 5.3 if we round to the nearest tenth. And the height of the candle should be twice the base, or 10.6. Now go ahead and take a look at problems 4 and 5. I'd like you to try those two in your groups. So if you can go ahead and press pause on the video player or press the space bar to pause it. Everyone can try 4 and 5, and then when it looks like everybody's had a chance to try those, maybe 8 or 10 minutes, go ahead and press play and we'll go over the solutions. For problem number 4, we have 15 cubic inches of wax. We want the candle to be in the shape of a cone, and we want the height to be twice the diameter. And so we start off with volume of a cone is 1/3 the area of the base times the height. The area of the base is pi r squared, and the height, we want it to be twice the diameter. The diameter would be 2r, and so the height is going to be twice that, which is 4r. And so in place of h, we could put 4r. And in place of volume, we want the volume to be 15 cubic inches because that's how much wax we have. So then if we simplify that, we get 15 equals 4 pi r cubed. This should have been divided by 3 because it's 1/3. And so this is 4/3 pi r cubed equals 15. And we want to solve for r. Again, you could graph the left side as y1 and graph the right side as y2 and see where they intersect. Or you can solve it algebraically, which I'll do here. So I'm going to multiply, to get rid of the fraction 4/3, I'm going to multiply by the reciprocal 3/4 on both sides. And so the left side is 45 over 4. The right side, the 4 and the 3 cancel with the 3 and the 4. So we have pi r cubed. And so then we get r cubed is equal to 45 over 4 pi when we divide both sides by pi. And then r would equal, if I raise both sides to the 1/3 power, I'd get 45 over 4 pi raised to the 1/3 power. And so I'll type in parentheses 45 divided by parentheses 4 pi. And raise that expression to the 1/3 power. And so I got that the radius needs to be about 1.53 or 1.5 if we're rounding to the 10th place. So the radius should be about 1.5. And we know the height is supposed to be 4 times the radius, so that means the height should be about 6. 4 times 1.5 is 6. And those are both in inches. All right, and then problem number 5, we have a prism with an octagon base, and we want to figure out what the height should be in order to use 50 cubic inches of wax. So the first step, since we know volume is the area of the base times the height, we first need to find the area of the base. And the base is this hexagon, and the way that we find the area of a regular polygon is to just find the area of one of the triangles and then multiply by 8, because we'd have 8 of these triangles that make up the whole octagon. And so we need the base and the height of this triangle. Since it's 3 inches across, then the height of my triangle is 1/2 of that, so that's 1.5. And so the area of one triangle is 1/2, 1.2 times 1.5. And that is 0.9. So that means the area of my octagon base is 8 of those, so 8 times 0.9, that is 7.2. And so now we can fill that in for the area of our base, 7.2. The volume, we want that to be 50. And we don't know the height, that's what we're trying to solve for. So I can easily solve that by dividing both sides by 7.2. And we get h equals 50 divided by 7.2. And that's about 6.9. So the height of our candle needs to be 6.9 inches. So that completes the lesson for today. You can go back and watch any of this if you need to again. It will be on my website under the video lessons link. Have a great day.